All right, so if I remember, right, section 1, we learned about polygons, the sum of the angles in a polygon, and how to find a single angle like in a regular polygon. And what I mean by that is that, let's say I have a hexagon, and I tell you it's regular, which means all the sides are equal, all the angles are equal. How could you figure out what one of those angles was? So what's the sum of all angles in a hexagon?
All the sides minus 2 times 1.
Yes, all the sides minus 2. So 6 minus 2 is 4 times 180, right? 2 times 180 is 360. 4 times 180 is 720. So we know all the angles combined in here must total 720 degrees. So how can I find one of those angles? 6. Okay, so that was really that first section, was figuring out how to find the sum of all angles in a polygon, and then from there being able to find an individual angle in a polygon if it's a regular polygon. Why do I say if it's regular? Why couldn't I say any polygon? They're all equal angles if it's regular. If it's not regular, this may be different than this, may be different than this, but we know altogether they have to add up to 720. Okay, what about exterior angles in a polygon? If it's a hexagon, what's the sum of the exterior angles in a hexagon? And exterior meaning the ones outside of the hexagon? No. Thought I heard someone say it. 360. Yep, doesn't matter what size the polygon is. The sum of all angles, all exterior angles of a polygon is always equal to 360, no matter what. Okay, so those were kind of the two main points of section 1. Section 2 and 3 really correlated together, and we were dealing with parallelograms. And a parallelogram, what are some things we know about parallelograms? Opposite angles are equal. Right? And there were also, these are equal and these are equal, right? And we know these two are supplementary. We know these two are supplementary. Those two are supplementary, and so on. Okay, so if you're told it's a parallelogram, you can assume all of these things. And then in section 3, we learned if we just have a polygon and we aren't told it's a parallelogram, but we are told opposite angles are equal, can we assume it's a parallelogram? If we're told this angle equals this angle and this angle equals this angle? There were some postulates in section 3 of how you can prove something to be a parallelogram. Everybody remember those, or should we go back and review those? I'm going to take that as let's go back and review, Mrs. Reader. Okay. We could actually just do it from this visual here at the very beginning. If they tell you opposite sides are equal, you can assume it's a parallelogram. If they tell you opposite angles are equal, you can assume it's a parallelogram. If they tell you the diagonals bisect each other, you can assume it's a parallelogram. And there's one more, if I remember right. So I can find. So if the opposite sides are congruent, the figure's a parallelogram. Opposite angles, figure's a parallelogram. If the consecutive angles of a quadrilateral are supplementary, it's a parallelogram. If the diagonals bisect each other, it's a parallelogram. I think the other one you can do is if two sides are parallel and equal, it's a parallelogram. I was going to see if they showed that one. No, this is just showing it in the coordinate plane. Okay, so there are some, I think, some problems in the set that you have to use the distance formula to show that the opposite sides are equal. And then you would use the slope to show opposite sides are parallel. So you could do both to prove parallelograms are parallelograms in the coordinate plane. Does anybody have a problem they're working on in section 3 that they're struggling with that you want me to work on the board? You're all finished with 3?
Section's done except for 6.1.
You're stuck on 6.1?
Yeah.
So what's the problem you're stuck on?
It's I just don't know.
Okay, the problem says, which sum does not belong with the other 3? The sum of the measures of the interior angles of a quadrilateral, the sum of the measures of the exterior angles of a quadrilateral, pentagon, interior, pentagon, exterior. So if it's a quadrilateral, what's the sum of the angles in a quadrilateral? How do you find that out? What's the formula? How many sides are there in a quadrilateral? Okay, so what do I do to find the interior? Okay, so what is that?
180 plus 180 is 360.
Yes, 360, okay? So the sum of the measures of the interior angles of any quadrilateral are 360. The sum of the measures of the exterior angles of any quadrilateral, any polygon really, is 360. And the exterior angles of a pentagon is also 360, so the one that doesn't belong is that one that you've got marked.
Yeah, but
And then how do you find the sum of the angles in a pentagon? Take 5 minus 2 is 3 times 180, and that's the sum. Anyone else have questions on 6.3, or because this is your chance to have me do one of your problems for you?
I could grab my combo chart.
Yeah,
Number 14.
14 on 6.3.
I think we just, I don't know. We just set those equal to each other, right?
If it's a if it's a parallelogram, yeah, the diagonals bisect each other. So we know that 6x would equal 3x minus 2.
it's a convex.
And then you just solve for x.
Can you help us with number 10? Figure that out.
Number 10, opposite angles are equal. So you'd set 4x minus 13 equal to 5x minus 12.
And then those two.
And then you'd solve for x. Once you know x, you can plug it in here and set those two equal. Okay, I will let you guys just keep working then on catching up.